So our system of naming, or our nomenclature strategy, is one in which we want to have a name that corresponds to a unique substance. So we want a name that unambiguously correlates our name with a single chemical species, so that when we communicate the name of a compound, we automatically know what that formula is. So because there are many different types of chemical compounds, it is necessary for us to devise rules that are as simple as possible and at the same time unambiguous. And so the strategy requires us to understand what types of compounds we're dealing with. That is, we need to classify which type of compound and apply the appropriate nomenclature rules. So we are going to be talking about a number of different kinds. We are going to begin here in this short lesson talking about simple binary compounds that are either ionic compounds like sodium chloride, or they are covalent compounds like carbon dioxide. And then we will extend these rules to slightly more complex compounds that contain polyatomic ions. And finally, we will describe naming strategies for acids, which require their own set of rules. So again, we are going to begin here naming binary compounds. And so we define a binary compound as any compound that contains only two types of elements. It does not necessarily mean it's diatomic. There can be more than two atoms, but there are only two types of elements. And these binary compounds fall into three different categories, and I categorize them as type 1, type 2, and type 3. So both type 1 and type 2 are binary ionic compounds. That is, they contain a metal and a nonmetal. And so a simple definition of ionic compound for now is going to be any compound that contains a metal and a nonmetal. So our type 3 binary compounds are those that do not contain metals. So they will be contain two nonmetals. Examples, and we'll see some examples of this. Now, for our three different types of compounds, our naming strategy is slightly different for the three. We will begin talking about type 1 binary ionic compounds, and these are really the simplest compounds to name, and they involve a type 1 metal, which I will elaborate on in a minute, and a nonmetal. We also have type 2 binary ionic compounds, and these also contain a metal and a nonmetal, but the metal is different in that is typically a transition metal that can have more than one charge. And so we will go into these rules in just a moment. So as we're naming a compound, we're going to follow a systematic strategy. We are going to first determine, is this a binary compound? That is, does it contain only two types of elements, or does it contain more than two types of elements? If it is a binary compound, we are going to ask, is a metal present in this compound? If it does not, this falls under our type 3 rules for nonmetal, for two nonmetals forming a compound. If it does have a metal, we need to determine what type of metal. Is this a type 1 metal that only has one possible charge? Or is it a type 2 metal that can have more than one charge? And so we're going to have to distinguish between these two types. So again, in our ionic compounds, our type 1 is a metal that has only one positive charge. And these are the ones that we can very easily predict their charge by their position in the periodic table. So group 1 metals like sodium and potassium will always have a +1 charge, whereas group 2 metals like magnesium and calcium always have a +2 charge. Okay? So these ones are going to be very simple, and we're going to start talking about those. Our type 2 metals typically are transition metals, though not always. There are a few examples that are not transition metals, but these will be things like iron, which can have two different oxidation states. We can have an iron ion with a +2 charge. We also have iron ions formed that have a +3 charge. And so we're going to have to figure out how to distinguish between these two different ions, and we'll go over those rules. For now, let's talk about the simple ones, these binary type 1 compounds. And again, this is a metal and a nonmetal in which the metal cation can only have one possible charge, like those main group elements. So let's take AlCl3 as an example, right? Here we are going to identify the cation and the anion. The cation in this case is aluminum, right? And it's has a formula of Al3 plus. We have 3 aluminums and 1 chloride. So again, when we name cations, we simply name that cation as its parent element. So the aluminum 3 plus, Al3 plus, we simply call aluminum. Then we're going to identify our anion, which in this case is Cl minus. Now in the compound there are 3 of these Cl minus ions, but in this designation, when we form the compound AlCl3, because aluminum is always a +3 charge, when it forms an ionic compound with chlorine, it will always be a 1:3 ratio to balance that charge. And so we're going to name this anion chloride with the IDE ending, indicating that this is an anion. And now we are simply going to combine the names of the ions, always beginning with the cation, that is, with the metal. So we'll name this compound aluminum chloride. So we always start with the cation, the aluminum goes first, and then the anion. This is true for our formula as well. We always have the cation before the anion. So these are our type 1 binary ionic compounds. And let's do one more quick example, such as, let's go with calcium and oxygen. So here CaO is our formula. We look on our periodic table knowing that calcium has a +2 charge and oxygen has a -2 charge, and so they come together in a 1:1 ratio. And now when we name this, we simply name the cation and then the anion. So our cation is calcium, and then our anion is oxide, again indicating that negative charge with the IDE ending. Next, we're going to talk about our type 2 binary compounds.